Hello students. So to learn the pipe flow, we have to start with the momentum equation. So momentum equation is based on the law of conservation of momentum or on the momentum principle. That is, net force acting on a fluid mass is equal to the change in momentum of flow per unit time in that direction. That is, F is given by mass multiplied by acceleration. Acceleration is the change in velocity with respect to time. So A is equal to dv by dt. That is, F is equal to m dv by dt. So this can also be written as d by dt of mv. That is, derivative of mv with respect to time. So this equation is known as the momentum principle. It can also be written as F into dt, which is equal to derivative of mv. This equation is also known as the impulse momentum equation. Okay. Now we will learn the forces exerted by a flowing fluid on a pipe bent. That is, we have a pipe which is bent and fluid is flowing through that pipe. So there is some force that the fluid is exerting on the pipe because of the bend in the pipe. Okay, so this is the figure of the pipe and you can see it is bent in this location. So we consider two sections in the pipe, section 1 and section 2. So at section 1 we have velocity of flow as v1. The fluid flow direction is shown in the figure. These arrows, if you see these arrows, the fluid is flowing in this direction. So at section 1 the velocity of flow is v1, the pressure intensity is p1 and the area of cross section is a1. Similarly, at section 2 the velocity of flow is v2, pressure intensity is p2 and area of cross section is a2. Direction of flow is indicated in the figure. Please keep that in mind. So now let's consider Fx and Fy, which are the components of the forces exerted by the fluid on the bend. See, this is the pipe through which fluid flows. This is the direction of flow. So here there is a bend in the pipe. So fluid flowing from here will come near this location and exert a force because of the presence of this bend in the pipe. So that force is resolved into two components, that is Fx, the horizontal component, and Fy, the vertical component. So since the fluid is exerting a force on the pipe will also exert a force backwards on the fluid. Okay, so that will be opposite to the direction of the force exerted by the fluid. So Fx and Fy are the forces exerted by fluid on the pipe, then minus Fx and minus Fy will be the forces exerted by the bend on the fluid. See, Fx and Fy are the forces exerted by the fluid on the bend, then minus Fx and minus Fy are the forces exerted by the bend on the fluid. Okay, this is okay, so that is clear. Then there are other forces which is acting on the fluid, such as P1A1 and P2A2 in sections 1 and 2. Okay, so now let's see here. Net force acting on the fluid in the direction of x is equal to rate of change of momentum in x direction. So this is what we saw in the momentum principle or the momentum equation, that is, net force, okay, is equal to rate of change of momentum. We are considering only x direction here. Only x direction is considered here. Okay, so net force is force in section 1 minus force in section 2. So at section 1 we have P1A1 which is the one force acting. And at section 2, we have in x direction the horizontal component of the force P2A2. Okay. If we consider section 1, force P1A1 is horizontal. There is no vertical component for that force. If we consider here, the fluid flow is in an inclined direction. So the force P2A2 has two components, horizontal component and vertical component. So we have taken here P2A2 cos theta, which is the horizontal component of the force P2A2. So P1A1 minus P2A2 cos theta minus f of x, which is the force exerted by the bend on the fluid. Okay, the fluid exerts some force on the bend and the bend exerts some force back to the fluid. So that force is minus fx. This is equated to the rate of change of momentum, which is the mass multiplied by the change of velocity. So mass here is given by rho into q, that is density multiplied by discharge. And change in velocity can be obtained by final velocity subtracted by initial velocity. Okay, and velocity is also in the direction of x. So we have rho q is equal to v2 cos theta minus v1. Here we have like this because v1 in section 1 the flow is horizontal, so velocity has only one component, that is the horizontal component. But at section 2 the flow is in an inclined direction, so the velocity v2 is in inclined direction, so it has two components, a vertical component and a horizontal component. So since we are considering the x direction here, we have given as v2 cos theta. So finally we find out fx, which is given as rho q into v1 minus v2 cos theta plus p1a1 minus p2a2 cos theta. Okay, similarly this is the equation for fx. Similarly you have the equation for fy, which is given by rho q into minus v2 sin theta minus p2a2 sin theta. So the resultant force Fr is given by square root of fx square plus fy square, and angle made by the resultant force with the horizontal is given by tan theta is equal to fy by fx. Okay, now let's see the problem on pipe flow. Okay, here the problem is given. A 45-degree reducing bend is connected in a pipeline. The diameters at the inlet and outlet of the bend being 600 mm and 300 mm respectively. Find the force exerted by water on the bend if the intensity of pressure at inlet to bend is 8.829 Newton per centimeter square and rate of flow of water is 600 liters per second. So here if you see the figure, you can see the bend is shown in the figure, that is a 45-degree reducing bend is shown in the figure. Okay, then you have the diameters at the inlet and the outlet. The inlet is at section 1 and the outlet is at section 2. You have the diameters of the inlet, d1 is equal to 600 mm and d2 is equal to 300 mm. You have to find out the force exerted by the water on the bend if the intensity of pressure at the inlet is 8.829 Newton per centimeter square. A rate of flow is also given as 600 liters per second. So we know the angle theta, which is equal to 45 degree, that is given in the question. Then we know d1 and d2. From that we find out area of cross section at section 1 and area of cross section at section 2. Okay. After that, we know the pressure intensity at section 1, which is given as P1. We convert that into Newton per meter square, and Q is also given, which is 600 liters per second, which comes to 0.6 meter cube per second. So we find out the velocity of flow at section 1 and velocity of flow at section 2. V1 is given by Q by A1 and V2 is given by Q by A2. Okay. So after finding out V1 and V2, we have to apply Bernoulli's equation at sections 1 and 2. So Bernoulli's equation is given here, that is P1 by rho g plus V2 square by 2g plus Z1, which is equal to P2 by rho g plus V2 square by 2g plus Z2, and we assume that Z1 is equal to Z2. That is, there is no difference in level between the two sections. So what is remaining is these terms. So we substitute the value of P1, which is the pressure intensity at section 1. Rho is 1000, G is 9.81. Rho is 1000 because the fluid under consideration is water. Again, we know the velocity at section 1 and the value of G. Here we know the velocity at section 2, the value of G, and P2 by rho G is kept as it is. So finally, we find out P2 by rho G is equal to 5.5575 meters of water. And we know the value of rho is 1000 and we know the value of G is 9.81. So substituting all that, we get P2 is equal to 5.45 into 10 raised to 4 Newton per meter square. Next, we will find out the forces on the bend in x and y directions. That is the force exerted on the bend by water. So Fx is equal to, this equation we have derived earlier in this video. Fx is equal to rho into Q multiplied by V1 minus V2 cos theta plus P1 A1 minus P2 A2 cos theta. And Fy is given by rho into Q multiplied by minus V2 sin theta minus P2 A2 sin theta. Here we know the quantities rho, Q, V1, V2, theta, P1, A1, P2 and A2. All these quantities are known. So we can find out Fx and Fy. Okay. So after finding out Fx and Fy, we can find out the resultant force which is asked in the question. It is given by square root of Fx square plus Fy square. So the final answer is 20,890.9 newtons, and the angle made by the resultant force with x-axis, that is tan theta, is equal to Fy by Fx, which is given by 0.3175, and theta comes to tan inverse of 0.3175, which is 17 degrees and 36 minutes. So hope you understood the problem. Now work out this problem and upload in your classroom. Thank you.